Let's talk about how to test microservices. So I've been doing software development and testing for more or less 12 years now. And what I wanted to talk about is a case study of a global media company that have decided to move to microservices and Kubernetes and Docker. And that organization was focused on quality quite a lot. So the quality was very important to them. And they've embedded it across the whole life cycle of software development. And what I wanted to focus on is how developers and testers focus on the quality so that we can get a wider picture of how they fit together actually when it comes to testing microservices. So one thing that I wanted to mention was that this story started around 2 years ago and it's still ongoing. So there's going to be, some of you might already be into the Kubernetes world, Docker world, and you might know some, the latest features, something that's come out, let's say 3 months ago, something like that, and you might not see it here, for example. So what that means is basically these guys are not there yet. But hopefully, what we're going to get out of this is their QA approach to making sure everything works in the new microservices world. So this organization, they've started developing this new product, and the problem they had was that they wanted high availability and they wanted to go to market faster. So what they've decided is to use microservices running on Docker and Kubernetes to achieve those goals. So what I wanted to also keep in mind is that this is not a recipe that you can just take and apply to your organization tomorrow. I want to keep in mind that what happens is that the company culture, the team structure, and how you structure your projects and different applications are going to inform how you do your quality assurance. So this might be applicable to you, or parts of this might be applicable to you, but please don't treat it as like, this is the only way to do testing of microservices. This is just an example how it worked for this very company. And having said that, it was a large company, and they've already had an established quality assurance process. So they've kind of applied that process that they already knew to the new microservices world, and that's how they ended up with what we're going to highlight here in a few moments. So some of you, maybe, hopefully, there's different types of teams. You're going to have teams where there's no testers. You're going to have teams where there are testers embedded within the teams. You're going to have companies where testing is a separate function, so there's going to be a separate teams of QAs. There's going to be some companies that test by outsourcing the testing function. And all of that is going to inform how you test your microservices here as well. And hopefully, or maybe you're going to disagree with some of the things I'm going to say here, especially when it comes to this new movement that's getting a bit more mainstream recently, DevOps, TestOps, or DevTestOps, however you want to call it. And if you disagree, just keep in mind that we've mentioned that it's the context that probably makes you disagree with what these guys have actually done for testing microservices. Anyway, so enough of the warnings, and let's have a look at how they've actually tested those microservices. So there were two departments working together. So they had this front-end department and back-end systems department, and those departments talk to each other via services and APIs. And in the front-end systems department, they had a few teams. There was a development team, a QA team, a support team. And in the back-end systems department, they had different teams. But what happened there was the QAs and developers and business analysts were on every team in like smaller groups. So they were like cross-functional product teams. And in the front-end systems department, what happened was they chose to develop with separate teams. So there was a large development team, large QA team, and a large support team. And the way that informed how they designed and tested their application. So they had the front-end application that was a big application, but since they had the back-end systems were developed by these cross-functional teams, they started working on these individual microservices that were managed by those separate teams. And why I'm talking about that? So I hope we're going to notice very soon that the way those teams were structured is going to inform how they tested their microservices actually. So this is how the production environment looked like. So you had this bare hardware environment UI application developed by that front-end system team. You had this new Kubernetes production environment when they kept on adding new microservices. There's just 4 here for just to demonstrate the example, but there was a lot more than that. And they had these third-party systems where they had to connect to and gather data or send data. So is there anything unclear about this diagram? Because we're going to base some testing scenarios based on what we see here.
Yeah.
Go ahead.
The bare hardware environment, I'm a little bit confused.
Yeah, good question, sorry. So bare hardware means they just had boxes somewhere in the data center,
Right.
and they put those applications directly on those boxes. Whereas the contrast here is Kubernetes, which means you're going to put it into a cloud, right? It's not like a real cloud, but you put it somewhere that abstracts you away from actually, you don't know where it's running. You just define that there's going to be 3 instances of your application or microservice, but you don't know where it is actually. Whereas the UI application, you have to put it on this very box, etc. All right, cool. So I hope what we're going to notice is when we're going to be testing all of those components that we just saw, is that we're going to have a component under test, which might be a microservice or a group of microservices, for example. We're going to have somebody that's testing, using a testing tool to test those components, and possibly then using an automated test runner to run those automated tests. That's going to be done in some environment. There's going to be different environments. And they're going to use an API mocking or service virtualization tool to decouple themselves from the rest of the world. So that means they're going to be testing just one component. So hopefully this pattern is going to start emerging when we take a look at the examples of how they've actually tested it. So first of all, we're going to look at the development and how developers have done it. And the purpose of this is, are there any developers here actually? Cool. So the purpose of this is that hopefully we're going to notice that the developers have done something, but then the QAs are going to kind of do it again, and that was done on purpose in this organization. Anyway, so what the developers have done in their local environments and then the continuous integration environment was that they would test their individual microservices using this YADSpec and Fluid BDD frameworks. Anybody know Cucumber, for example? So these are frameworks similar to Cucumber. They just have one thing turned around, but it's a very similar concept. And they'd use TeamCity for running those tests. So you probably know TeamCity, Jenkins. Yeah, so those types of tools to run those actually tests that the developers have created. Those tests would test one microservice running either on their laptop or their desktop or in a CI environment in a Docker image. And they would use a tool called WireMock to mock the other services. Anybody heard of WireMock? So WireMock is a tool that's going to pretend or simulate the other non-existing components, so then you can actually test this guy in isolation. So once the developers have done this, they would proceed to testing the actual, not the microservice, but the configuration of the Kubernetes bit. So how the microservice gets put onto the Kubernetes cluster. So the way they did it, they used Minikube. So Minikube is a thing that allows you to simulate or run Kubernetes on your laptop or desktop, for example. So you don't have to go to a special environment. You can actually test the configuration on your laptop or desktop. And again, they would use curl to simply test that everything more or less works. So again, looking at the production environment, you can see that the microservices are talking to each other here in different ways. So you want to make sure that this API that this microservice here has is actually compatible with what this other microservice needs. So the way the developers have done it, and we're going to have two diagrams here that are going to go quite deep. So if you want to switch off for two diagrams, that's fine. The main point I'm trying to make here is that developers tested here the contracts between microservices, and then the testers are going to test them again. And just quickly how they tested it, so they used the PackJVM framework, and they've written consumer tests using this PackJVM framework, and once those tests have been run, they produce artifacts that get published to a JFrog artifactory. And then on the other side, so real microservice A, so we had microservice D was the consumer of those APIs, so this is the producer of the API, which was microservice A, uses again the same framework, pulls those artifacts or definitions of those contracts, they get run, and make sure that, if we go back to this diagram, this contract, producer-consuming contract, is actually satisfied according to developers. Then developers are done with testing, and we go to the QA world. So QAs come in and start testing these microservices, individual microservices, in isolation again. So remember, developers have tested them. Now the QAs start testing them again. Anybody know Postman? Cool. So these guys use Postman to run those API tests, and they've used, in this case, Traffic Parrot to decouple themselves from the other microservices. And they would be running these tests on their desktops, actually, using Docker. The type of errors that you get in here is mistakes that the developers might have made so they would just code some acceptance tests or unit tests, and they would make stupid mistakes, like, for example, any human can make. Let's say you've got a user ID that gets passed in here and needs to end up in these two requests as well. But what you can see in this type of environment is that if you test it again and pass in a user ID, and sometimes it didn't get passed to one of the other calls. So it's not easy to spot in. It's easy to make the type of mistake if you're writing automated tests, but once you actually go again and start looking, manually exploring what happens in this microservice, you're going to see those. It's easier to spot those errors. So that's an example of a bug they would find in this type of this first stage of testing. Then the QAs, so again, we got, let's say, microservice A and microservice B. They're talking to each other here. So there's a contract that needs to be met between those APIs. So the QAs would test those contracts as well. So they would use Postman again, and they would make sure that these two APIs can talk to so that this microservice A can consume with no problems the API that's provided by microservice B. So that's the second stage of testing the QAs would do. What then they would do is, this is the first stage they're testing in the Kubernetes test environment. They would test groups of microservices. So let's say you're developing a new functionality, and these three microservices have been changed to allow for that functionality to work. So what they would do is deploy these three microservices to the Kubernetes test environment, and again test them in a group. The types of errors you typically find in here is the complex interactions between them. So let's say you need to go here, fetch something, go back and do something in microservice B, and that interaction, the complexity of that interaction would result in different types of bugs being found. And the other thing was that you can set up here, you're not integrating yet with the third-party systems, the real third-party instances of those systems. So what you can do here is you're going to be simulating different types of responses. For example, let's say this microservice B communicates with a third-party system using file transfers. So what you can do is simulate what happens, for example, if instead of 50 lines in the file, you're going to get 100 or something like that, which wouldn't be that easy if you worked with the real system, actually. And then they proceeded to the next stage of testing. So again, we're testing these 3 microservices that have been changed very recently for a new piece of functionality. But this time, we're testing them together with third-party systems. So the types of bugs they would find in this in this setup would be the discrepancies between what we saw in the documentation of these APIs and what actually happens with those real systems. And it wasn't uncommon that these systems actually behave differently to what was specified in the documentation. And again, so we've kind of tested everything here. We haven't tested this guy yet. So what they would do is, that's UI application existing for quite a while. So, and those QAs from that front-end team, they used the IBM tool to test that application for quite some time. So they've decided they're just going to continue doing that. But they didn't want to integrate and have to set up the test data in the whole microservices world. So what they've used is an API mocking tool to decouple themselves from that and test this UI application in isolation. The interesting bit was that they actually never tested both of those, this Kubernetes cloud of microservices together with the application before going to production. So the first time the real instances met was actually in production. But because of the contract testing that they've done here, there was actually no issues, which we're going to touch on in a second. And lastly, but also importantly, the developers would write performance tests. So an important bit here is that they were done together with databases. They use Oracle database. So in here you can use Oracle XE that's going to run on your local and CI environment inside a Docker image. And they would populate a lot of data to that database, synthetic data, and make sure the SQL queries and the microservice works with production-like synthetic data. And what they would be doing is they only tested individual microservices in isolation, performance tested individual services in isolation. They would never test multiple services together in a performance suite of tests. So we've mentioned in the beginning that they were after high availability. So they were used to this bare environment hardware, bare hardware environments where they knew actually what was causing availability or downtime. They just knew if one of those nodes goes down, that means something's not available. And here in Kubernetes, you define that you want to have 3 instances of this microservice, 10 instances of the other one, but you actually don't know how it gets managed until you understand the internals of Kubernetes. So you can kind of trust that it's going to do what you tell it to do, but you actually at the end of the day don't really know, which is what these guys found. So what they've done was in one of those Kubernetes test environments started switching off the microservices and observing what happens if, let's say, I told Kubernetes to have 3 instances of this service and I bring 2 of them down. And what does Kubernetes do? Let's say I bring 3 of them down, and what does Kubernetes do? And what they found was it's easy to misinterpret the documentation of Docker and Kubernetes, and there were slight differences to what they expected is going to happen versus what actually happened. So there was an interesting interesting thing to do where they've gone to the Kubernetes environment. They had a developer, tester, and a support person sit together and just basically go SSH to one of those nodes and bring down the microservice and just see what happens. And I'm not sure if you've noticed, but they had many microservices. We just had 4 here in our diagram. But what happened was they never integrated all of those microservices together. So there was no one suite of tests that would ever test all of them together. But they still had no bugs in production. And the way they've achieved this is with this contract testing. So the developers would write those contract tests and run them, and then testers would make sure those contracts actually work again. And one more thing you've probably noticed was that in this case, the testers wouldn't do much automation. And the way the QA process in this organization worked was that the testers would be kind of double checking what the developers have done, and most of the time finding a lot of very important bugs or misalignments to what was actually supposed to be delivered versus what was delivered, and working very closely. They would do some automation, but the automation would be to automate the daily tasks that they had to do, not automating the actual tests. Whenever there was something to be introduced to those tests, they would work together with the developers, sit together, and make sure it actually gets added to the suite of tests. And I hope we've kind of noticed the pattern that some people don't like the testing pyramid, some people like it, but the point I'm trying to make here is that every organization is going to have one. And in this organization, more or less looked like this. You had, from the QA's tester's point of view, you could draw something like this, that you had a lot of component tests of individual microservices that were done for a new piece of functionality that was delivered. Then you do a bit of contract testing, integration testing, and maybe a bit of third-party integration. But the most testing was done on the individual microservice level. And one more important thing was that they did a lot of monitoring of the production environment. So since you don't have just one thing that's either up or down, but you have tens or hundreds of them, you want to know what's going on. And what they've done was every microservice had a special status page. So you'd go to /status, and it would tell you in a JSON format what's going on with it. And then you could just plug it into whatever tool you wanted to plug it in, and they used Nagios because that was the tool that was already there. And so the result they've observed was that in the following 12 months, they found 0 critical bugs. So there was not even one situation when somebody had to be called and come in, later in the evening and try to fix something. There were 2 major bugs that could be fixed just during the day. So the quality of the product was quite high. So here are a bunch of things that we've kind of learned back then when it comes to testing microservices. And first of all, the obvious thing is the more microservices you have, individual bits, the more APIs you're going to have, and the more components you're going to have. That means the more things you have to test on that level. You have to keep in mind that in the microservice world, some companies might decide to move to microservice-specific protocols, like gRPC, for example, which is used for scenarios where latency is an issue. So you don't want to use HTTP1 and JSON, for example, because it's too slow, and people decide to move to gRPC. So we're going to have to keep in mind that you need 2 tools, not only Postman, for example, which supports HTTP, but you're going to have tools for API testing that support those types of protocols as well. And if you, again, imagine you've got a bunch of microservices that talk to each other over a network, a big part of that infrastructure is actually the network. So if something goes wrong on the network, you have a problem. And there's a lot of those connections, so there's a higher chance compared to a single monolith application of the network impacting your product. And there's certain scenarios where what you're going to see is that a single failure of one of those connections can cause the whole stack to go down. And I'll show you a video where somebody explains it in more detail how that can happen. So it's important to remember that even one connection that goes down can bring down the whole thing. And that's not the case in if you get just a single application, because there's not that many network connections. Obviously, more components, the more components you have, the more components you're going to have to performance test. And one thing that wasn't very visible in this organization, but that some people observe, is that a lot of QA teams are used to testing from the user's point of view. So what happens if the user goes to a website, or what happens if the user clicks something in the application, etc. In this microservice world, sometimes it might not be possible. You're going to have to switch the mode of testing from what user does to what the applications do between each other. And probably that's one of the bigger risks on this list. So there's some technical risks, but one of the big risks is you have to keep in mind that you might have to switch your perspective as a tester from testing from what the user thinks to what actually the internals of the system do. And yeah, a bunch of resources that I would recommend if somebody is interested in looking at these things, and especially the testing approach. So there's going to be some more details that explain how people do it. So yeah, that's pretty much it. Do you have any questions?
What were the microservices?